Okay, 22, 23, and 24 all ask for the horizontal asymptotes. And this doesn't take very long if you remember. It has to do with the degrees. You have to compare the degree with the numerator and the degree with the denominator. Since the degree of the numerator is a 1 and the degree of the denominator is a 2, the degree of the numerator is less, let's see, the degree of the numerator is less than the degree of the denominator. And when that happens, your battery saver just came off. Your horizontal asymptote is the x-axis, which is the equation y equals 0. Okay? Now, on the next one, my degree of my numerator is the same as the degree of my denominator. So when the degree of the numerator equals the degree of the denominator, you take the ratio of the coefficients, that fraction right there. So my answer is y equals 5 halves. And then the last one is the only other situation that it could be. And on this one, the degree of the numerator is greater than the degree of the denominator. And when that happens, there is no horizontal asymptote. Now, it's possible that there's an oblique one, but not necessarily. So that's a totally different question, which is coming up next. So that's those 3 questions. So 25 asks for the oblique ones, and in order to do this, you need to do either long division or synthetic division. And I'm just going to do another example of long division just so you can, just so you can see what I'm doing. I'm going to take the denominator of x plus 5 and you divide it into the numerator. And you start with the x and you divide it into the x squared. X goes into x squared x times. And then you multiply that times the x plus 5, and that gives you x squared plus 5x. And then you subtract. These should cancel. And then -4 minus a 5 is a -9x. And then you drop down the next number and you divide again. You divide x into the -9x. That would go -9 times. And then you multiply and get -9x minus 45. And then you subtract. Those cancel. 2 minus a -45 is a +47. Now there's no more to drop, which means this is the remainder. But when you're looking for the oblique asymptote, it is simply your quotient. Whatever you get for your quotient. And so you're just going to say y equals the x minus 9. Doesn't matter if there's a remainder or not. So it's just the quotient that you need. Okay, this one says solve the inequality f of x equals blah, 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 blah. This is I can look at this. I'm looking at my function and I know that this is a smiley face parabola because it's a positive x squared. I just need to know where it crosses the x-axis. So I am going to set this equal to 0 and factor, and I'm going to get an x plus 5 times an x plus 7 equals 0. So it crosses the x-axis at -5 and positive 7. I'm just going to give you a visual on this. So down here is -5, up here is positive 7, and our parabola, it's too big, is a smiley face. So it comes down, hits -5, curves somewhere, and comes back up again, right? That's what it looks like. And it crosses here and here. Now, they wanted when f of x, go lime green, they want when f of x is greater than 0. So when is this function greater than 0? Remember, when they say f of x is greater than 0, they're looking for the points with the y coordinates that are positive. They want to know, where is f of x greater than 0? Where are the y coordinates greater than 0? Where are the y coordinates that are positive? Y coordinates are always positive in quadrants 1 and 2. That would be here and here. Any of the points on that part of the graph have y coordinates that are greater than 0. Now it doesn't say equal to, so I cannot include these 2 points here. And the answer will be an interval notation for the left side over, let's see, over here, this part here, it would be from -infinity up to the -5, but don't include it. And then union that with purple, this side over here, that's going to be starting at the 7, but don't include it, and going to infinity. This is the solution. Any point in that domain, all of those x coordinates have y coordinates that are positive.